all of the concepts we learned in Extension 1, they can actually be applied to all the formulas that we learn in 3D vectors as well. So for example, something like this, right, here's our vector, we have our notation, -1, 2, 3. We're going to look at a few questions related to this. So we're going to find things like writing it in component form. We are going to do things like find, what does this mean again? Magnitude. Find the unit vector, u hat. And we can even do things like this. Because of the fact that all of these concepts that we learned in Extension 1 can be applied to the 3D vectors, right? There's no real new formulas, but I guess the variables have slightly changed. Now we have 3 variables, right? But the same idea still applies. When we add vectors, we add the x, y, and now z components. When we find the magnitude of vectors, you learned that that was like the same as taking distance formula, right? We can just apply that to all 3 variables now. Same thing with u hat, right? When we want to find a unit vector, what did we have to do before? Divide by the magnitude, right? So same ideas with this one. Component form is, I guess, a bit more interesting now, right? Because before, the component form was talking about the fact that we have what we call these unit vectors. They're 1 unit long. So we had the x and y ones, we called them I and j, right? And now we obviously have our z unit vector, and creatively we call that k, right? Just using all the letters of the alphabet. Yeah, just kidding. All right, so writing component form. So u is going just to be -I plus 2j plus 3k, and we have that in component form. They'll alternate between component form and this like column notation as well. Sometimes they use like row notation. This is probably more common though for vectors. Sometimes they'll also use square brackets as well. All right, magnitude, Angus. Yeah, so look, so we've got square root of -1 all squared plus 2 squared plus 3 squared. And yeah, looks pretty good. Square root of 14. All right, C. Emily, what are we going to do here? So this is our u hat, right? So it's a unit vector. So when we talk about this, a unit vector, we can actually take any vector and let's say -1, 2, 3. So that looks like this. -1, 2, 3. Maybe somewhere here, right? So this is why we, again, generally don't draw these because it's very hard to draw, right? But a unit vector is saying, okay, I've got this guy. I want to like shrink him down so that he's only 1 unit long, right? So right now, if he's root 14 units long, right? Because we have the magnitude, now what we can do is we can just say, all right, because we can use our Extension 1 ideas, that's just a scalar, right? So we can reduce it down by multiplying by 1 on the magnitude, the reciprocal of the magnitude, so that we actually can create that unit vector. And you can write it in a few ways, right? You could write it using this column notation. So this would be u hat. Or we could also write it like in component form as well. So that would look like this. Okay, so far so good. D. What do you reckon about D, James?
I do not.
So yeah, think about what like the question is asking, right? And I think I like the visual idea. It's just hard to represent, right? So we've got this vector u, and we know that once we have it in its unit vector form, what's good about it? Well, when it's in its unit vector form, I know it's 1 unit long. What kind of things can we do with vectors where they have magnitude and direction? We can multiply it, right? So if I knew that it was 1 unit long, how do I make it 3 units long? Yeah, and multiply 3, and then to change the direction, opposite direction, we multiply by that negative value, right? So you're applying these same ideas that we've learned before, right? So we just take out, and I'm going to stick with column notation here, right? So V now, I want to combine both of those. That would just be -3, and then we can put in now. Oh, hang on. That's not quite right. -3 multiplied by our unit vector. So that would be root 14 there. Okay. And we can like summarize this in formulas as well. And I think it's always nice to do that. So this is what they do. So the vector R. Okay. Alright, so two forms that we can use in 3 dimensions.